Hey guys, today we're going to talk about acid-base indicators and start pH a little bit. There will not be homework over the weekend. You'll have some homework on Monday and a virtual lab on Tuesday. So if you can open up to page 4 in your packet, you're going to need colored pencils or crayons, or I suppose you could just write the colors in on the thing we're going to fill out in a minute. All right, let's get started. Oh my goodness. Okay, there we go. Okay, so we're gonna start looking at table M, and it looks like it's a more confusing table than I think it needs to be. Acid-base indicators change color when they react with acids and bases. So this is the reference table you would use, table M, and it tells you the indicator on the side, the color change range, and then how the colors actually change. So how to read this is anything before the first number is the first color. So we have red. All right, so anything after the second number is the second color, yellow. And then anywhere in between is the mixture of the two colors. So red plus yellow make orange. Okay, so litmus right here, less than 4.5 is red, greater than 8.3 is blue, and red plus blue make purple. Okay, so this is where you're going to need some colors. All right, so let's do the first one. So I'm going to do red. Okay, so methyl orange up to 3.1 is red. So I'm just going to mark 3.1. And you guys could shade it in red. I'm just going to do my best here. Okay, so that's red. Above 4.4 is yellow. So that means all the way to 14. This is the pH scale. Okay, and then in between you have orange, because red plus yellow make orange. Those are kind of tricky, hard to see. Maybe I'll just label them. Okay, so orange, and then above is yellow. Okay, on the next one we have bromethymol blue. So less than 6 is yellow. It's going to be yellow all the way to here. Blue will be above 7.6. And then yellow plus blue make green. So it'll be green in the middle. Okay, next one, phenolphthalein. So phenolphthalein, when it's less than 8, is colorless. So I'm just going to write that in, and I would tell you guys to do that too. So colorless up to 8. From 8 to 9, it's light pink. So if I could, I would shade it in just really lightly here. And then above 9, it's going to be a dark pink. So in the middle is a light pink, and then above is a dark pink. All right, on litmus, we have red to start. So less than 4.5 is red. Okay, then we have blue. Above 8.3 is blue. So I'm getting the numbers from the chart. I'm not just making them up. And then in between, purple. Okay. We have yellow to blue again on the last two. So for Brome Crystal Green, yellow to blue is yellow up to 3.8. Okay. Above 5.4 is blue, so it's going to be blue all the way. And then in between is green. Okay, and then same on the last one. So looking at my colors in the chart, less than 8 is yellow. Okay, above 9.6 is blue. And then in between is green. And then once you're done coloring, flip to page 5, and we're going to talk about the kind of questions that you would see with that. Okay. You might want to have your reference table handy, or just be able to flip back and forth to this chart. Oh, shoot, I should. So if I was smart, I would have left this color thing here. Okay, but I didn't, so great. All right, so now looking at question number 1. It says, which solution will Brome Thymol Blue turn blue? Okay, so if I look at Brome Thymol Blue, it's blue anywhere above, above 7.6. So above 7 is a base. So that means your answer has to be a base. I am like on the wrong one. Sorry, guys. Okay, here we go. All right, so now if I look at my choices, and I could use my my reference tables that we looked at yesterday to look at the common acids and common bases. This one's in there. CH3COOH is acetic acid, so it can't be that. This one is in there also. Hydrochloric acid, also it starts with an H. This one's in there too. This is your only base, ends in OH. Okay, number 2. Which solution, when mixed with a drop of litmus, will cause the indicator to change from blue to red? So now I'm looking here. So the change from blue to red, so for litmus, it's blue above 8.3, and it's red down to 4.5. So that means to change it from blue to red, I went from a base to an acid. So these are all going to look like bases. This one is not a base, even though it has an OH because it's with carbon. But this one's a base. That's a base. This is an acid. Okay. All right, moving along onto the next page. Okay, so number 3 says, what is the color of Brome Crystal Green if the sample has a pH of 6? So if I'm at 6, I'm right here, I would look at my Brome Crystal Green. Up to 3.8, it is yellow. I really wish I left this up. Above 5.4 is blue, so it would be blue. Okay, and then 4 and 5 are a bit trickier. So in number 4, it says, if a sample turns colorless in phenolphthalein. So I'm going to look at phenolphthalein, and it's colorless up to 8. So this is how I like to set it up. 0 to 8, it's colorless. You don't have to write colorless. And then it's purple in litmus. So litmus is purple in the middle. So between 4.5 to 8.3, it's purple. So then it says, what is the overall pH range? So that means where does it overlap? So if this one turns colorless less than 8, but this one turns purple only between 4.5 and 8.3, I know that my overall range has to be here to here. So it's just saying, where do those two colors overlap? And that is between 4.5 and 8. So number 5 is the same thing. So let's talk about that. And then we'll move on to pH. If a sample turns yellow in methyl orange, so let me find methyl orange, and it says yellow. So yellow is above 4.4. So it would be 4.4 to 14, it would be yellow. And bromothionyl blue is also yellow. So that is yellow less than 6. So from 0 to 6 would be yellow. So then to find the overall pH is where do they overlap? So they overlap in this small range between 4.4 and 6. So basically, like, you find the two kind of middle numbers of your, like, if you draw your number line, that's what it would be. Okay, let's see where we're at for time. 11. So I think we can start pH, and then we'll wrap it up on Monday. Okay, I just don't want you to have too much for Monday if we leave it till then. Okay, so we'll just get started briefly with that. All right, so pH stands for the power of hydrogen, which basically just measures the strength of an acid. Okay, so pH is 0 is a strong acid, so it's very acidic. And then a pH of 14 is very basic. And then 7, remember, is neutral. Okay, so because we're talking about pH and pOH, pOH is a measure of base strength, but we're not going to talk about it. What I want you guys to know, though, is that acids contain a lot of H's. So when they're dissolved in water, they contain a lot of H+. But since you're in water, you're also going to have OH-. So even though it's very acidic, you might have a tiny bit of OH. So very acidic has a low pH. That also is something that's tricky, because you have a low pH means you have a high concentration of H+. Okay. If you're very basic, you have a high pH with a low concentration of H+. So you have more OH than you would on this side. Okay, so let's see. Let's look at the first two together, the first two problems. I think we'll be able to finish this off in the next like 5 minutes. Okay. Okay, so now that you know like what is in the pH scale, this is how the numbers are related. So increasing acidity is going towards 0. So where you have high concentration of H+, lower pH. Increasing alkalinity means basic. You have less H+ concentration here. Okay. And then in between each number on the pH scale is actually a factor of 10. So a pH of 8 is actually 10 times stronger of an acid than a pH of 9. And then if you went multiple places, 10 times 10, pH of 2 is 100 times stronger than a pH of 4, which is why you can drink things like soda, which has a pH of 4-ish, but you might not want to drink something with a pH of 2. Okay, so I'm just going to show you the first two, and then I'll have you guys try. There's 4 more, and they're really simple, and then we'll be done with this section. Okay, if the pH goes from 3 to 6, so 3, 4, 5, 6, by what factor does H plus change? So I'm going to do that part first. So in between each number on the pH scale is a factor of 10. So basically all you need to do is count how many spaces, and it would be 10 times 10 times 10, 10 to the third, which is 1,000 times, and then more or less acidic. So since I'm going up to 6, I'm going to look at the scale. It gets more acidic as you get lower. So that means it gets less acidic as you get higher. Okay, number 2, it becomes 10 times less concentrated. So we start at 4, it gets less concentrated, mean less acidic. So it has to go this way. It only changes by a factor of 10, which has 1 0. So that means 1 spot. So the new pH is 5. So I'd like you guys to flip to the next page, page 6, and try questions 3 through 6. And then after you hit unpause, you can listen to the answers for those. All right, so number 3, if an acid becomes 100 times more concentrated, so 100 times 2 zeros means it's going to move 2 spaces. I don't know if you can hear my kids, but I don't know what they're playing. And I start at 5, it becomes more concentrated, meaning I become more acidic. So I move 2 spaces, my new pH is 3. 4, if the pH goes from 12 to 8, so 12, 11, 10, 9, 8. 1, 2, 3, 4 spaces. So 10 to the 4th, or 10,000 times. Does it become more or less acidic? Since the number is getting lower, it becomes more acidic. Okay, number 5. If the pH becomes 10,000 times less concentrated starting at 2, so it starts at 2 and it has to move that way if it's becoming less. And then I look at my number 10,000, it has 1, 2, 3, 4 zeros. So that means it moves 4 spaces up. So 3, 4, 5, new pH is 6. Okay, and then the last one, number 6, the pH of an aqueous solution changes from 4 to 3. So 1 space, so it increases or decreases by a factor of 10, we know that for sure. And since it's going from 4 to 3, it's getting more acidic, so it increased by a factor of 10. Okay, and then we'll pick up there. We'll finish up pH on Monday, and you will have a homework assignment on Monday regarding pH. Okay, so have a great weekend, and I'll talk to you soon.